Hello and welcome to our podcast. My name is Jose Betancourt. I'm studying chemical engineering, currently in my second semester. I'm 19 years old and I study at Universidad ECCI.
Hi everyone, I'm David Suarez, also chemical engineering, studying in the second semester. I'm 20 years old, and I'm happy to be here with you today. We both studying at Universidad.
Today we're talking about collisions and how they are used in chemical engineering. Collisions between molecules and particles are part of many chemical processes.
Yes, collisions are not just about physics or sports. It's for field. They help explain how molecules reach, transfer energy, or even break apart in industrial processes.
Let's begin with elastic collisions. These are collisions where kinetic energy is conserved. We usually find this behavior in gas molecules in ideal conditions.
That's right. In gas, molecules more than collides constantly. These elastic collisions are important. We calculate reaction rates with the kinetic theory of gas.
Now, in inelastic collisions, some energy is lost, often turned into internal energy. This is especially useful in chemical reactions that need activation energy.
Like when a molecule is at catalysis superphase, the energy of the collisions helps start the reaction by weakening chemical bond.
One example is the fluidized bed reactor. It uses gas to move solid particles like a fluid. These particles collide constantly and improving heat and mass transfer.
Yes, this helps keep the reaction on uniform temperature and makes the reaction more efficient. It also helps prevent problems like hot spots.
In starry tank reactors, we use an impeller to create mixing. The turbulence causes many collisions between molecules and gas bubbles, improving the mass transfer.
And better mass transfers means faster and more complete reaction, which is exactly what we want in industrial processes.
Collisions are also used to break particles. In ball mills, metal bolts hit particles crush them. This is useful before chemical treatments like leaching.
We can control the size of the final particles by changing the wall size, the rotation speeds, or the time the mill runs.
One more thing, collisions can be dangerous too. In high pressure systems, particles collide and can create static electricity, which means cause explosions.
That's why engineers must design equipment carefully and control conditions to avoid accidents.
So, collisions are not just about movement, they are part of how we control and improve chemical reactions.
I hope the podcast help you understand how important collisions are in chemical engineering.
Thank you for listening. Bye.
Goodbye and see you next time.